Hello everybody, we are back again, guess to debug this. So I've pondered on it a little bit and figured we just need to add a bunch of debug. So let's just remind ourselves of the problem. Problem was, when you compare these two, the number here that's missing, 14369, is on the live site but not on the test site. So I think we just need a bit of debug here. Oh, a bit of debug. So if number equals this, then print line. We had some nice debug earlier, didn't we? We can get that back. Where? GitHub. Should be able to grab it from the branch. Remove debug. Okay. We just want this. Begin with, let's just output the number. Nothing too dramatic. I wonder where that would go. Is that going to console log or is that going to error? Maybe we could just have our cargo test. In fact, no, we added a test, didn't we, to catch this. If I run cargo test, we should see. Well, I wasn't expecting that. 1, 4, 3, 4, 5. That number, that's the one we're missing. Let's compile this again. Let's just curious, isn't it? My history doesn't seem to contain compile command that I'm after. Let's see if I can find that again. Control R WASM. There it is. I just got to search for the right thing. Hopefully this might just magically work with no input required. Wouldn't that be lovely? The number's still missing. So, okay, this is quite curious. I wonder what could possibly be being passed into this page that would give us a different result. So I guess it's going to be searching for 100 and been told to be limited to 1,000,000. So let's do the same. First of all, let's try limiting it to 1,000,000. So we can get a different cargo test out of it now. Cargo test is still good. And can ask for 100 numbers. That'd be okay. So it fails, but that's to be expected. because we've got 100 numbers instead of 3. Okay, but the first 3 match up. So then the other thing we could do, we get the first prime on the page, goes in there, and we know in this case we can hard code the number is 1600. That we get for the test. Okay, so this makes absolute sense because actually it's around number like 75 that fails. So if I say return me 75 numbers, please. We should see, so it's 14249, so still not quite enough. Maybe it's 85 numbers. One, 4, 3, 6, 9. 4, 3, 4, 7. 1, 4, 3, 6, 9. That is really confusing. So that means during a unit test, this returns the number we expect. Running in the web browser, it doesn't. All right, what if the number 14369 was actually not prime? Primality checker. Ugh, much. Something simple. It's a proven prime. Okay, so it is a prime number. What a strange bug. Okay, how about we do compile this? And then if I refresh this, do we get that debug? I'm fairly sure print won't work when it's compiled to WASM. It'd be nice if it did, but yeah, it doesn't. Rust WASM console output. Yeah, how can I use this? Maybe this is going to be more complicated than I expected. Take a look at binding console.log manually without the help of WebSys. Alright, maybe we do have WebSys, so is there a simpler version? Works for the actually work. Yeah. No, I didn't want that. Maybe it's something like this that we want to do. So we need to, okay, so I think we will need a utils function, or maybe this would go in the library function. I'll put it in here for the moment. So this would be function, make it public. Yeah, yep. maybe I can't do it that way. Or using websys. So we'll get websys.console, console.log. I quite like the look of that. Okay. So does this potentially mean can maybe use that inside a function? Yeah, apparently we can. Let's see if we can. Copy that, paste that. A lot of copying and pasting going on today. Function. Does that compile? Yeah. Okay. So now, what if I specify string? And I probably don't need this. Or do I? Do I need that? Got a feeling I possibly don't. Let's try it without. Let's try it without. And then we've got this log function now that we've just written. So in theory, I can instead get some really basic output. Might complain about the namespace. Yeah, okay. I think this is just specify crate, and then in theory. Okay, so this is saying mismatched types. So it's saying mismatched types because that is a number and we need a string. Then it will probably complain saying I wanted a borrowed string. Yeah, okay. We wanted one of these. Cool. Let's recompile that. See if we get some debug now. At the moment, we've got nothing here of note. Okay, now twice it spits out 14369. But no mention of it here. So what would be interesting is if I move this after the for loop. Actually, no, maybe I don't. Maybe I put it, will slow things down quite a bit, but maybe I put it in here. Get rid of this, and we can say rate.log. So at this point, we think this is prime. Then go and set a whole bunch of numbers. We can say num squared is no longer prime. Truly hate debugging sometimes, but don't know how to get a... I guess it'd be nice if we could have like an interactive debug on this. I just don't know how to do that. Okay, so is prime 14369, is prime 14369. Doesn't display it though. So it doesn't set it to be not prime. So then the next thing to do is just to make sure this entire while loop is doing what it's supposed to be doing. And say, oh, I didn't actually mean to do that. I didn't mean to wipe that out. We can say, does this still equal true? And if it does, say, still true, still prime. And then, of course, the final test will be after this filter has run. So potentially, if this still comes back as it's still prime, maybe this is to blame. Although I'm not sure how yet. Okay, that's reloaded. Is prime, but somehow it is no longer prime. That's num squared. That's bad debug. Try that again. Okay, let's read that. Okay, so it decides it's no longer prime. Why does it do that? Why does it do that? Is this some strange wrapping issue? That would be a guess. Is no longer prime 14369. It rhymes totally unintentionally. I'm sure that has nothing to do with it. Num squared and equals num. What does it start off? Num squared. So we're saying 14369 times 14369. While that is less than or equal to end, and in this case end would be essentially quite a large number. End is 1,000,000. That's not going to be enough, is it? That's definitely not going to be enough. So end is going to come in at 1,000,000. So whilst num squared is less than or equal to 1,000,000, which it won't be, because a very quick calculation of taking 14369 and timesing it by 14369 will yield a result that's greater than 1,000,000. Yes. So then this shouldn't even run. So it shouldn't run. What is num squared? What kind of number is this? It's U size. So what's the largest number you can store in 32 bits? I think we might be onto something here. I reckon this is wrapping. Although Wikipedia has a nice answer. 2.1 billion. And I'm pretty sure we said, why do I keep doing that? 21469. Okay, don't know what that number is. 14369 squared. Well, it's under. That's technically under. So what's the difference? Have we got, maybe we've got if we allowed for negatives, so Rust U size versus, oh wow, Cannot type. Let's have a look at like i64. I guess we could probably do this all with i64s. I don't think it's going to be this, but we could convert it to a 64-bit. Let's do that, shall we? U64. I wonder if num could then be U64 as well. Okay, mismatch types. Expected U64 but found U size. You can convert U size to panic if the converted value wouldn't fit by using try into. Alright, I'll do that. Thank you, compiler. Try into, and then I believe it recommended running unwrap so that we lose the... What did I get wrong? No method try into found for type U size in the current scope. Items from traits can only be used if the trait is in scope, and we would need standard convert try into. Okay. Use standard, and I think it was convert lowercase try into uppercase. Oh, I thought that was going to work. The compiler we trust. Oh, you know what? That's outside of the module, isn't it? And that's why it's highlighted, because it doesn't see any usage of it. So if I put it inside the module, that should go away. That won't error. That's now happy. So while num squared is less than or equal to end, problem is that at this point, end, this is messy code, right? I'm just doing this for debug purposes. We'll tidy this up in a second. And of course, now this isn't going to work because isPrime starts off as what about, okay, I've got an idea. Got another idea. Let's bring back the original. This is the original one. This is the value that we had without my faffing around, right? So this should compile, except it'll say this isn't in use. That's fine. I'm okay with that. What I would like to do though is I would like to log both of these. Actually, you know what? I only want to do that if and only if this is true. I suspect if there's wrapping, these two would be different. Not sure why that's still unhappy, isn't it? Our variable doesn't need to be mutable because we don't change it. Fine. When did we change num squared? Oh, I see. We add to it. Right. So we're looking for 14369. Refresh. Still doesn't appear. That's not what I was expecting. Ah, you know what would be useful here actually is if we got to 14369, what number did it think that was divisible by? That would be useful as well. So let's grab that. No longer prime. Visible by, and then this should just be num. Now we're saying this is unusual. See what we end up with. Such a shame to get stuck on this bug. Otherwise, we could just roll this out across the site. We see thousands of times speed up. Wow, okay, that's quite a bit of output. So is prime, this is unusual. That's curious. We only got one number. Very peculiar. Hit refresh on that. We're not persisting the log, are we? No. Let's clear the log, refresh that. Okay, so this time it ends up, maybe it suppressed the fact, maybe the same message twice gets suppressed. Fine. Is prime, this is unusual. So those two numbers match, so there's probably not an overflow issue, which kind of makes sense because the number was less than what we could fit in a 32-bit variable. But it's claiming that the number is visible by 146,000. What? Why would num equal 146,000? Oh. Oh, actually that might make a bit more sense. So when num equals this later on down the line, I reckon that's when we run into the overflow issue. This will make sense. Reasonably sure this time we're going to get, this is unusual, we'll get a number, it'll say vary, and then we'll have a different number. And that means there is an overflow issue. It is doing some wrapping. Refresh. Clear this. Refresh. What? Did I'm confused now. Recompile that. Maybe I missed it. Maybe I refreshed after before I'd finished compiling. Maybe that's what I did. Divisible by. So at this point, oh, I see, because it's been adding, it's adding to it. So num squared. Maybe this causes some weird overflow later on. I'm convinced there's an overflow issue. I can't prove it, which is a shame, admittedly, but I'm convinced there's an overflow issue. So let's just check. This number doesn't magically appear now. No. So that was the code before I started messing around with it. Fine. So whilst num squared is less than or equal to end.try into unwrap, fine. Is prime num squared, which is 64-bit at this point. No, it's not. Okay. See what we come out with. Oh, that just outright breaks it. All right, well, we can do something with that. Index out of bounds. So the length is 1,000,001, but the index is 1,000,002. Fair enough. Fair enough. So let's give you more numbers. I suspect it's just going to say exactly the same thing, but the number will begin with 5 instead of a 1. Yeah. Okay, so what line does that actually error on? Panic to index out of bounds, and then there's 1,000,000. Huh, actually that I didn't expect. I thought we had that. It only says 5,000,000. Oh, this first one could be upset. Rerun that. Still 1,000,000. Okay, that's quite confusing. Where in the code are we specifying? Oh, of course. So up here, rather than the unit test, so if I put the unit test back to 1,000,000, still maintain it's really weird that it works in a local unit test, but I guess the difference is we're compiling it to WASM. So maybe when it runs cargo test and we're using usize, all of this stuff is 64-bit, but when we run this in WASM, all of this stuff is 32-bit. Okay, so to prove that, what I will do is I would like to have these. If I just change all of these to 64-bit, is that going to work? Or is it then going to get super upset saying, oh no, you can't do that? I guess that's the first thing. How upset does it get about this? This type U64 cannot be indexed by standard operation. Slice indexer of type usize or ranges of usize. That's a shame. Which types expected U64 found usize, so they'll probably fix that one. So this becomes U64, U64. See what we end up with. Now it complains about start. Expected usize found U64. Is that because PR is 32-bit? That's usize. That's U64. So here, can I specify U64? Is that okay? Or does that not? It's probably not going to work that way because filter map probably gives us guessing 32-bit integers. Or usize stuff rather. Okay, so that's just not valid Rust. Not okay. What could we do? We could try this. Feels a little hacky, but seems to be okay. Function collect. What's wrong with that? Let's try running unit tests and see why this errors. 5 errors. Wow. Collection of type standard vector 64 cannot be built from standard iteration iterator item usize. Okay, is that because when we've defined is prime, we haven't defined a vector of U64s, which I've got a feeling we can't do. I'm reasonably sure Rust will complain. Let's start at the top. I've lost where we are. Okay, I'm gonna hit return a few times, run cargo test. Wow. Expected U64 and found bool if is prime. Expected U64 found bool. Oh, it's not a vector of U64, it's a vector of booleans. Right, so I get rid of some of those errors. Expected U64 but found usize, so that's numbers per page. Line 127. Where's that get set? Here. Yeah, so what if it wasn't? What if this was U64? Then what? And again, numbers per page, found usize, so that's probably set up here. Again, U64. Try running that. Expected usize, found U64, so that's on 163. So is that complaining that I is? No, that's a different error. Let's read this one. The type U64 cannot be indexed by U64. Okay, so that probably means here we need to convert this. Let's deal with that in a minute. So it's going down to line 163. Mismatched types. Expected usize, found U64. I mean, we know that these are going to be fairly small. So I feel like we should just be able to use that into code, which I've already lost. There it is. Try into. I hate the amount that we're using this, by the way. I'm gonna see if we can tidy this up before we commit it. I just want to see if we can actually get it working. No method name trying to found. Okay, so that's probably because we're outside of the module now and it wants to use that. Cargo test. Okay, slice indices of type usize or ranges of usize. And another one, line 103. Okay. Is there a reason why that had to be usize? Boolean can be in by U64. Okay, we've got this down to a few less errors now. Wow, maybe not that many. Yeah, so what if n stayed as usize? Will it cause us problems? Let's deal with this one. Slice indices are of type usize or range as usize. I think Google might be our friend on this one. Or DuckDuckGo. Yes, why are all indexes of usize? Only supports t being a usize. This is just not true. Okay, cool. Any type slices only allow you to index them using usize, as do all container types. Past in the past, but adding smaller types be backward incompatible. Okay, so what do we do? How do I fix this problem? Is there a workaround? It's not too dissimilar, but no one answered the question. Right at the bottom, clues that the trait is implemented for usize and various usize ranges. This should answer both your questions. Indexing is not implemented for U8. We need to cast it to usize. So slice indices are of type usize. So line 138, do we need to do a try into there? Is that what we're saying? Slice indices are of type usize or ranges usize. Oh, I see. So when these are returned, these are 64-bit. I think we need a try into. Really disliking these try intos. I'm going to maybe put this into our own function in a minute. Surely that's as hard. This is Craig versus the compiler. I mean, the compiler's going to win, absolutely hands down, because the compiler's right. So we're on line 136. Slice indices are of type usize or ranges usize. So when you say a slice, what do you mean? Are you referring... Are we taking a slice of primes? In which case slice indices are of type usize would mean that I is somehow 64-bit integer and needs to be a 32-bit integer? No. Okay. The other option is... Oh, did not mean to do that. We have a sieve and num that is specified here needs to remain a 32-bit. In order for it to remain a 32-bit, end has to be usize, so that's fine. This we wanted to convert to a 64-bit, and we did. Is prime num squared. I wonder if we could have this only work up to 2 billion or something. To be fair, 2 billion is like 2 gigs of RAM. So when we say sieve n primes, why would we change this? What was it before? So it started out with a start of usize, which I think is fine. I think that's fine. An end of usize and the number of primes also usize. Why would that not be okay? Let's backtrack a bit. Now we're saying the start expects to be a 64-bit integer. What if it's not? What errors then? Nothing in here. Okay. But something down here. So then we had our try into. The collect still complains. Collect still complains because we're saying we're returning a vector of U64s. Sieve to numbers. Why are we still expecting 64-bit anythings? I disagree. Slice indices are of type usize or ranges of usize. So that's line 138. I think we can fix this whole thing by just passing in a smaller number as the maximum length, by the way. I think that's the problem. But I've got to undo what I've just done. So this is saying something cannot be indexed by 64-bit something or other. Fine. So slug in used to be usize. Let's put it back to a usize. This says 5 million. I don't think it needs to be 5 million. Realistically, I think that's just absurd. Size is just fast. Really, I think that should be the square root of 2 billion. Square root of that, I wonder. Square root of this, please. 46,340. Okay, to do. I think we should turn that into a constant. In fact, let's do that. Let's have a constant. So I think that is the formatting we would want. So that would be const. I think we should say square root max 32-bit equals that. And we can even go as far as to say that it's of type usize. Hopefully it won't complain about. No. Okay. So therefore we now know what that is, 46,300 and something. So that should be fine. That in theory should be fine. Why is that erroring? So that's on about a U64 as well. So if I go here, usize, 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 that specifies U64. Get rid of that. No implementation for usize. Line 160. Interesting. Expected usize found U64. So where does this come from? Ah. That'll be that then. Okay. First prime on page. Where does this come from? Here. So that would suggest that this is returning a 64-bit integer. Yep. I think by now I would have just searched the code base for U64, see if anything else comes up. Okay, let's see if that compiles. And let's see if it runs. Test. Okay, one of them fails, but that's okay because I think our test was probably a bit on the ridiculous side. Oh yeah, and we had a perfectly good constant at the top of this page that was quite important. Let's try running that. And this should stop it from having the out of bounds error. So index out of bounds, the len is 11, but the index is 12. Yep, let's run this with backtrace on. I mean, it's good that we're getting this locally now. Okay, it's a mere 28 places for us to look in the code. Okay, index out of bounds, backtrace, backtrace, this calls slicing of things, mutable operations, sieve, line 77. Here. Oh yeah, we don't need this now because we got rid of it. Means we can probably use num squared. And this doesn't need to be a try into anymore. Actually, we need to make sure that num does not exceed the maximum allowed for a 32-bit integer, which we happen to know is 46,340. So, well, if we're going to square it anyway. So yeah, okay. Have a ponder for a second. Getting lost in the code. Lost in the code. Yeah. Let's tidy that up. So this should just use our 32-bit variable and it should be fine. We could also, if num is greater than square root 32-bit max, this frankly should error. This should throw some sort of error. At the very least, error num is too large for 30, too large if we square to 32 bits. But what's wrong with that? Cannot find value square root 32-bit max. It's because I'm inside the module. In which case, do I need to specify crate? And then do I have to specify some other stuff? Maybe I have to then specify prime. Because you've got the archive page. Well then, okay, maybe I need to specify archive then prime. Maybe that gives us the right namespace. Nope. What's wrong with this then? Unsolved import. Oh, yeah, I'll say. Unresolved import. A similar path exists. Create pages archive. Oh. Oh, okay. Alright. Fine. That should surely fix it. Okay, good. We've got a log. We should also do a print line actually. Definitely do a print line. Probably take this in here, and then I think, yeah, replace this, the variable, and the variable that we want to replace it with is this one. Give this a whirl. And actually, we don't want the backtrace because nobody cares about the backtrace anymore. Convert try into is unused. Fine. I care not for it. Create print line. Okay. Because I don't have to specify create. No. What's the issue then? Change to print line. Oh, it's a macro. Yep. Good if this just works. Index out of bounds. The len 11, but the index is 1004. Length of what? Length is 11. I feel like we broke something here. Like, if I go back to, where did we borrow this from? We borrowed it from here. Again. Limit. Limit is usize. But when we set up, this almost doesn't, this feels like it's broken. Let's say your limit is 100, then you're setting up is prime. Although it's a vector. Can you dynamically add stuff to a vector? I think you can. Maybe that's why this is okay. But even then, actually, that doesn't help us. Index out of bounds. The len is 11. So where would it be getting 11 from? We head back down to the unit test. Let's note out the last two assertion, or the last assertion. Okay, so it's still unhappy. So possibly one of these that's upset. Maybe even the first one. Okay, and then obviously if I know out all the assertions, this isn't going to error. Okay. At least some kind of sane reality exists here. So curiously, this ends up being one larger than we expect. We go to the sieve. Specify a start. We specify an end. Okay. Start off with end plus 1. I wonder if that is just plain wrong. I wonder if that should be end times end plus 1. Or just, I don't know. We square it at that point? Otherwise, I don't really understand why this is going way, way beyond. Although num squared, whilst num squared is less than or equal to n, so of course that's fine, that's not a problem. And this should prevent, I mean this here should prevent the overflow. Unless the problem is here. If I get rid of that plus 1, I've got a feeling this is just going to suddenly stop erroring. Although I've said that about 5 times on stream and every time it's continued to error, so there we go, again it errors. Ah dear. Where is this 11 coming from? Let's hide some stuff that doesn't matter. Let's get rid of this render function. Let's also do something obvious. If I change this to an 11, I would strongly expect this to then say an out of bounds 12. Sanity check. Bounds 12. Okay. So when we call sieve, end is being set to 11. And end is being set to 10. Here we're setting a mutable is prime. We're saying you can have 10 plus 1, so you end up with 11. Let's turn the backtrace back on. Let's just read through that again. Okay, so we run some tests. We panicked because of a try. Something was boxed. We ran a closure inside of sieve test. The only closure I know of is here. Right. Okay. So we ran a closure, and that was on line 200 and what? That wasn't what I was expecting. Oh, that's in the tests. That's in tests. Now we're up to line 85. Okay, so line 85. That'll be the error. I'm trying to access something that doesn't exist. So my debug created this latest error. Good job. It's amateur hour. Try this. Okay, this time it does an error. I created an error with my debug. Oh, that's something else. That's incredible. Let's what else what should we try and do next? Let's just check that our test case still compile this and check that we can manually still test this. Okay, we are looking for this number. What? So I've changed something. What have I changed? So this was a vector of U size. Now it's defaulting to whatever. We've got our unit test noted out. I can't believe that that's affecting anything. Something was here. Oh, it was a space. We've got some debug here. Let's get rid of this debug. Yeah, okay, great. Thanks. Yeah, let's get rid of this debug. And again, this just shouldn't happen. Yeah, this really shouldn't happen. So I'm almost tempted to note this out. Then what's going on here? Here I've specified that this should be a vector of type Boolean. I mean, all I seem to have done is specified some types at this point and added in this try into. Are we still using a try into? And where are we using that? Here. Maybe something was really messed up here. No. I get rid of that. Get rid of that. We're going to crack this. We're going to crack this. And the number's there. I'm gonna keep taking things away. I really want to find out what the problem is. On line 62, I just took away specifying that it was a vectors of booleans, or a vector of booleans. Still there. It's not that. That we decided was just some spacing. So it's not that. This did have vector usize and we took it out. I mean, I'll put it back in, but at the moment I don't understand how that can be the problem. check like other pages work, right? Four, 3, 6, 9, still there. Okay, so it's not space. I mean, I'll add the space, but that's just syntax. So this was specified as usize. But what I just changed that. Okay, was specified as usize. Let's put that back. Just slowly undoing everything that we've tried. I mean, it's not, I'm not going mad, am I? It's not, it wasn't a different number that starts going wrong. I guess the one thing we have changed is we've changed this max. Well, I think it must have been that. We could prove that by, I'm just going to compile it with all the tests. And then what I'm going to do is I'm going to compile this with this being 1,000,000, which is what I think it was before. And then we should see the problem reoccur. Still there. Okay, this should do it. This should recreate the issue. I'm like 7% sure. Yes, good. Good, I can rest easy. So it was a issue, an overflow issue. Good. I guess I could actually move this out for greater speed. I could put it here and I could check end because num is inevitably going to equal end. So if end is greater than this, I can say num slash end too large. Happy days. And check everything is fine here. Yes, it is. Okay, we can compile this now. Sorry, we can commit this now. Let's check what we've changed. Oh man, that was really quite challenging. Git diff. Okay, so I added that logging function. Cool. I might add the I might add that lib file separately. Source lib. There we go. So I can say added log function for web browser debug. Technically, we should only compile that if we're in debug mode. We could turn that into a feature. Now we can say we fixed memory overflow issue. Involving prime 14,369. Okay, that's pretty cool. I'm reasonably happy with that now. So if I go for like the millionth, oh, you know what? We're not running, are we? Let's push this. The first thing. Let's push this. And then having pushed it, let's compile it again. See how far we can push our local copy. it like the 10,000th where it started to get a little slow? 100,000? 100,000, that's pretty slow. Well, that errored. 100,000 doesn't work. Why is that? Index 100,000 out of range for slice length of 4792. Okie dokie. So it works for 1,000 numbers. So much clicking there. I think if I go for 4,400, next one kills it. No, 4,500, 4,600. Okay, so 4,600 kills it. 700. Does 4,700 consistently kill it? Yeah. Okay, well, I mean, the good news is it's fast. The bad news is it's broken. That's pretty quick too. All right. Why is this erroring? Next. Okay, panicked index 100 out of range for slice of length 93. Okay. So what if we tried to have a decent unit test for this? Mid-range numbers. More mid-range numbers. Okay, so that starts at 1,600. What if we started at 4,700? Get 3. Why would we get 85 in this case? Don't know. Run those tests. Let's see if that errors. Cargo test, please. Not unexpected. Sieve test failed. The left returned. The point is actually that failed. That didn't ultimately break. So the left returned 13499. What did we expect? It's a pretty small number actually. I wonder if that's this erroring rather than this. Because what I could do is I could be silly, right? I could make these silly numbers. Do that. Yeah, okay, so it's this one. So starting at 1,600. Sorry, there's a different error than I was expecting on a different part of the test than I was expecting. I go to 1,600. Go to 1,600 on big primes. The live site. We should see. Yeah, where are those three numbers from? That doesn't make any sense. Absolutely see these three numbers. Now if I run it, it'll fail on the second bunch of tests because that makes sense. Change that to run just 3 actually. Now that'll make sense. Yeah, okay, happy with that. So first of all, save that, and then we should commit this. Fixed erroring test for sieve test. It's a shame, when that hits CI, that's just going to complain now. That's fine. Okay, so then we've added this. So this should be 4700. We should have 45037. 45317. 45319. 5319. What's wrong with that? Oh, a typo. Typo 45307. Cool. That makes a lot more sense. Usually the human at fault, right? The squishy human bit. Okay, so unit test pass. And give us the right number, most importantly. The fact that let me just check that. So it was oh, I don't want to do that. Doing it now. It's happening. It's pushed. Let's compile. We might have to specify the first three numbers on 4800 to actually make it a real unit test, because if it's one of the last numbers in the page that's actually erroring on page 4700, yeah, then the unit test will pass. No, okay, so it could be I'm going to up this to 4800. This becomes 46447, 46451, 46457. All right, let's cargo test that. Keep pushing stuff. Cargo test. And that fails. Okay, good. So we've got a similar error now as we get on here. Some kind of slice problem, right? And I suspect if I go and compile this again and request that it load 4800, the errors will actually match. Try again. Slice of length 4792. Slice of length 4792. Okay, cool. So now we can get feedback much quicker. Now we need to fix this. So index 4800 is out of the range. So can we have some Rust backtrace, please? Okay, so can we see anything that looks remotely like our code? Yes, line 99. Fact. Get status. Commit. Added failing test. Failing test. That's it. That's all I'm going to say. I added a failing test. And give me the backtrace again. So here, slice index length fails. Line 99, that's where we got to, wasn't it? So here, it gets upset here. The n primes is not available. So whatever this has returned, there's not enough stuff for it to give us the data we need. So here we've specified first prime on page, square root max 32-bit. So this one's 4,800, this one's the number 3, and we don't know what start is. Importantly, we don't know what start is. We presume that that's a sane number. What if it wasn't? Let's print that. See what we end up with. Somewhere up here, probably before the backtrace. No, we didn't get a print. Oh, hang on. What if it's failing here? I didn't even consider that. It's quite possible that that's what's happening. Yeah. So we start to get output. And then nothing. Okay. So this is the problem. The first prime on page. So we're saying, starting with the number 2, going up to the square root of max 32 bits. We want 4,800 numbers, please. And then I just want the last one of those. So this is going to be 0 to 4,800. But the problem is going to be that we don't have 4,800 primes. Why would that be? I suspect because we've gone over this magical number. And that magical number is probably when we have to switch to 64 bits. Except we shouldn't have to. So I wonder... So both these cases, that would be 4,800. Then it goes into Sieve. Just realised I've just been sat and not really moved. Of course, that's what streaming is, but your whole body goes to sleep a little bit, doesn't it? Okay, so yeah, then we call Sieve with start and end. Start is like, end is like 46,000. And that's the problem. We can only check numbers up to that size. But that's not quite true. Definitely check larger numbers. Squared needs to be Another way. Bother. You know what? We've improved this. I'm wondering whether it's time for a break. We've definitely improved it. That can't be argued. Yeah, I'm going to leave it there, I think. I am going to give this some thought, as always, and come back to it. But we have improved it. We fixed one or two bugs. Now we're just onto a whole 32-bit, 64-bit problem, or some busted logic here that I just can't quite see. But yeah, cool. Thanks all. Catch you next time.